Welcome to the Qatar Open Innovation Program webinar. This webinar is a partnership between QRDI and Qatar Shipyard Technology Solutions. I'm very happy to be your host for this session today. Let me introduce myself. My name is Abdul Haq Balaidi. I'm QRDI Program Manager in charge of Qatar Open Innovation Program. My distinguished guests and panelists today from Qatar Shipyard, Mr. Gopakumar Nair is the Business Support Services Manager at Qatar Shipyard Technology Solutions. In his role, he leads a portfolio of functions comprising the shipyard annual business plan, business continuity and enterprise, risk management, crisis management, business performance tracking, sustainable development, environmental, social and governance, senior executive management services support, digital marketing and communication, technology collaboration and business innovation efforts in line with the Qatar Shipyard Technology Solutions vision, mission, goals, and objectives. Prior to joining the Qatar Shipyard, Mr. Nair has served as a commissioned military officer in the Republic of Singapore Air Force for 27 years and retired as Lieutenant Colonel. He has also served in the Agency of Science, Technology and Research in Singapore, A-Star, as a Deputy Director. In addition to Mr. Nair, we have the Qatar Shipyard Technology Solutions Subject Matter Expert, Mr. Praveen Menon, Manager Marine Projects and Production Control, Johnson Cheripuratu, Manager Planning, Scott JP, Shipyard Facility Manager, Maintenance Manager, Samrat Parab, Hull Manager, Steelworks, Selva Kumaran, Piping Manager, Vijay Raghavan, Punyamuruti, Senior Production Energy Engineer Piping, and Muhammad Yunus, Head of IT, Shipyard IT. Regarding the agenda of today, we will start by introducing the Qatar Open Innovation Program. Then I will hand over to Mr. Nair to talk about the Qatar Shipyard Open Innovation calls. Afterwards, I will show you how to submit the proposal or describe how to submit the proposal. Then we go to the Q&A session and we end this webinar. Let me say some words regarding the Qatar Research Development and Innovation Council. So the Qatar Open Innovation Development and Innovation Council was established in 2018 to drive research, development, and innovation efforts on national level in line with the Qatar National Vision 2030. QRDI Council has developed a 10-year strategy, QRDI 2030, which seeks to create locally empowered, globally connected RDI ecosystem, mobilizing leadership across government, academia, and industry to transform Qatar's social and economic future. Among the funding programs within QRDI portfolio is the Qatar Open Innovation Program that we are working on today. Qatar Open Innovation Program aims at connecting opportunity owners who are large local enterprises and government agencies inside Qatar with local and global innovators from all over the world. So we work with the large local enterprises and government agencies to identify areas where they want to pilot technology-based innovation in order for these entities to enhance their performance and competitiveness. After identifying this innovation opportunity, we structure it in a form of call for proposal, and we amplify it all over the world, seeking the best to receive the best solutions for this best innovative solutions. So we partner with you innovators to test pilot in Qatar. Through this program, we will facilitate the engagement of innovators with the large local enterprise and government agencies, and we will fund the initial pilot to be developed in Qatar. So here are the offering of this program for you as innovators. The first one is to gain access to funding for a pilot development in Qatar. The maximum amount of this funding is 100,000 US dollar. The second offering is a potential commercial agreement with large local enterprise and government agencies. So if the pilot or the POC turns to be successful, there will be a commercial agreement between the opportunity owner and the innovator. Third offering is to facilitate company registration process. If you wish to come during the POC or after a successful POC to establish in Qatar, we will facilitate the company registration process. We will also help you to gain access to the local incubators and accelerators in Qatar. And last and not least, you will have access to the Qatari market and the GCC market through our large local enterprises. So now here are the examples of large local enterprises and government agencies that we worked with so far since we launched this program in 2022. So we have large local enterprises that are globally known, like Qatar Airways, like Ooredoo, Milaha, our guest today, Qatar Shipyard. We have others that are regionally known as GWC, as Mada also, Sidra. And then we have the one that are locally known like Baladna, like Mada, and so far. Also, we have the government agencies who are ministries, basically. So far we worked with 20 opportunity owners, and here are some statistics for your benefit. So far we published 58 calls. 54 of them are closed. 30 projects were awarded so far, and then 10 projects are completed. We in the next I would say weeks, we will be awarding another 10 or 15 projects depending on the dynamic of evaluation. This is I would say a brief introduction of the program, and I will now hand over to Mr. Nair to talk about the Qatar Shipyard opportunities. Mr. Nair, the floor is yours.
Thank you, Dr. Abdul Haq, and once again, a very good afternoon from Qatar Shipyard Technology Solutions based in Qatar to all participants and attendees. I think we've got about 55 of you, so we are very encouraged by that. Also, a big thank you to Qatar Research Development Innovation Council for giving us this opportunity to partner them and collaborate on open innovation calls. So I'll run through a couple of slides which gives you an overview of the company and then our core business, and then talking about what we do and what are the innovations that we have lined up today. And as what Dr. Abdul Haq mentioned, at the end of the session, we can take questions or clarifications. So very quickly, Qatar Shipyard, we are an award-winning shipyard. So we've recently been awarded the British Safety Council 5-star for occupational and safety health for the third consecutive year since 2022. And as recent as last week, we were awarded the Safety and Security Award at the Maritime Standard Awards 2024. So we were inaugurated on 23rd November 2010. And as a shipyard, we deliver a range of ship and rig repairs. So when I talk about a range, we can talk about the various types of ships, from the very large ones to small ones, as well as rigs, which are used for drilling and offshore activities. We also do ship conversions, new build and fabrication of offshore as well as onshore structures, and industrial engineering solutions. And our aim is to deliver solutions and services that are safer, faster, and better to our customers. And in that light, we seek to expand our technology solutions and services to meet both the current, the emerging, as well as the environmental compliance requirements of both the energy and the maritime industries that we are working with, as well as some of the industrial engineering industries that we work with. Now, in terms of core business, we've got three main ones. First one is marine. So in marine, you will generally see what is stated there in terms of we work on vessels, a variety of vessels from the very big ones to the small ones, and rigs, lift boats, calm buoy repairs, upgrades, conversions, maintenance. And we also look at sustainable green shipping solutions, gas solutions, engine conversions, storage tank fabrications. And we also are able to put our people, our technical expertise on board vessels and travel with them and conduct both voyage and anchorage repairs. In terms of flying squad, we are able to fly our expertise to anywhere in the world and then work on vessels when they require repair or maintenance. The next one is on offshore. Here we are looking at new build structures or fabrication, conversion of both offshore and onshore structures, as well as subsea pipelines and modification and maintenance of offshore units. Moving on to the third vertical of our business, it's the industrial engineering part. So here we look at shore-based plants fabrication as well as refurbishment. We are also capable of doing both the electrical and mechanical equipment refurbishment as well as machining of large components. And last but not least, we are also able to provide a specialist manpower group for plant shutdown jobs. So the way we are organized is very quickly, we've got 5 production sections, namely shipwright, electrical, steelworks, piping, and mechanical. And then we've got an engineering arm, which takes care of mainly the design and support for the various projects that we undertake. And overseeing this aspects of it are the projects and production control, where my colleague Praveen is from, and planning functions where my colleague Johnson is from. And in terms of support capabilities, we've got both safety and quality, that is the HSSE, and the quality part, QSA. Then we've got facility and maintenance, which is represented by my colleague, Mr. Scott. And then we've got commercial and marketing that takes care of the business development, procurement and supply chain, finance, IT, and business support services. So this is how we are organized. Next slide, please. Can we move to the next slide? Okay, so this is an overview of how. Can we go to the next slide, please? Yeah, so this is how the shipyard looks like. So we comprise, you can see docks as well as piers, jetties and quays, right? As well as fabrication laydown areas. And then we also have a small vessels repair berth with dedicated floating quay and mobile boat hoist to take care of the small vessels. And surrounding these operational facilities, we've got all our production support facilities, which are the ones that I've highlighted earlier on. And of course, our administration, safety, quality, and operational facilities. So we are located within Ras Laffan Industrial City, which is one of the industrial cities in the state of Qatar. So that's where we are located within Qatar itself. Next. Very quickly now, go on to the key points related to the respective innovation calls that we have lined up. The first slide, please. So the first one, excuse me, is on digitalized and dynamic shipyard operations plan and yard layout. And moving on to the next slide. So very quickly, I'll run through what are the challenges and the solutions that we are seeking. So currently we're using various systems like Excel, SAP, Fiori, Primavera, and Honeywell. And these combination of systems are used for planning and managing of projects. And that is to make sure we are utilizing our manpower, our assets, and our resources and our yard facilities in an optimal manner. So while we have all these existing systems, they are time consuming and inefficient in the sense that the various data that we require for the planning as well as for production control, it is not available in a single interface, and that needs to be drawn from the respective systems and then manually plotted onto the Excel for planning and execution. So with that in mind and looking at what's not available in the market, we are now trying to develop an integrated system for the planning process that is specifically suited for shipyard operations. So what are we looking at in terms of the ideal solution is the development of a real-time digital operations plan that is integrated with certain features like an editable layout of the yard, digital layout of the yard, and one which is interactive. And like I said, it should be a digital layout so that we can actually see all our facilities and be able to work on them as well as update them as we go along. So in that sense, we need the data from the operations plan to be fed into the digital yard layout in real time. And then any edit that we make to the digital yard layout should also feed back into the operations plan. So it should be an interactive and iterative process such that plotting and scheduling of vessels in both the digitalized operations plan and the digital yard layout are always aligned. And that's essential to make sure that we get a very optimized operations plan. So we'll go to the next slide. And in the next slide, we will highlight what are the requirements. So the requirements for plotting and scheduling of vessel locations and durations are to, first of all, plot and schedule the vessel locations and durations based on the data, which is manually input from the various source documents that I've highlighted earlier on, and also allow real-time manual editing of both the input data and the scheduled vessel locations as well as the durations. And then be able to also realign and reallocate all related vessel durations and locations real-time based on manual edits. Now, vessel durations and reallocation are necessary dependent on the scope of work as well as whether they need to be performed on the piers or within the dry dock. So that's how we optimize our assets and our resources to perform the respective job scope on the respective vessels. And then we must be able to pre-program these digitalized operations plan with specific conditions and restrictions. And these are, for example, there are restrictions and limitations on crane utilization, the kind of vessel size, the space requirements for docking and undocking. And also, if anyone actually exceeds this or provides data or inputs into the digital operations plan, which exceeds the pre-programmed specified conditions and restrictions, then the system should be able to generate caution notifications where such inputs or edits would result in the breach of the pre-programmed conditions. So that's the requirement here. Now we will move on to the next innovation. So we're done with the innovation one. We will move on to the second one, which is on the digital asset and predictive maintenance technologies for shipyard operations. Here, the challenge is that we've got a floating dock. Just to give you a perspective, that's not a challenge. It's actually a facility that we have, key operational facility, a floating dock that measures 405 by 66, and that operates alongside two QMAX. These are very large vessels. We call them graving docks. They are basically dry docks where we carry out major repairs on the hull portion of the vessels, and also at the vessel berthing and at the various piers and quays. So there are many industrial equipment out here to support both the operations of the shipyard facilities as well as to overall keep the facilities of the shipyard going on, both for operations as well as for non-operations purposes, like safety and security. So we have got equipment ranging from dry dock gates and winches, dewatering, ballast pumps, hauling winches, floating dock, manufacturing and repair equipment like a variety, which covers cutting, press boring, welding machines and utility equipments, as well as essential equipment to run the shipyard like fire pumps, the water network, industrial fire water tanks, generators, water treatment systems. And these are systems that have been in operation for more than 15 years. And currently, the maintenance of these equipment are through SAP maintenance software, but printing of job cards, communication, and action plans, these are administered manually, and that leads into a labor-intensive operation, and that limits our responses in terms of emergency responses. So we want to speed it up. So to overcome this, we've got what we call an asset integrity team. So they have started an initiative called a condition-based maintenance, and they have established the baselines for the selected major and critical equipment, which is carried out on demand and with independent measuring devices. So the next slide will actually share with you what are the solutions that we're looking at. So the solution that we're looking at is a single centralized digitalized platform or a single task-dependent tool that could be integrated to a centralized platform, and that will allow us to manage the critical equipment. And with that, we are also looking at expanding this particular system to cover over 20,000 separate assets. So the integrated system that we are looking for should have remote monitoring of critical industrial equipment in terms of vibration warnings and analysis, audio warnings and analysis, thermographic temperature warnings and analysis, partial electrical discharge warnings, as well as operational performance. So we are looking at potential artificial intelligence monitoring of equipment, a predictive capability, early warning, adaptive maintenance plan that allows scheduling based on condition and asset life cycle assessments. And also, one more requirement is to assess the end of life and life cycle costs for potential replacement or write-off of the respective equipment. We'll move on to the next slide. In the next slide, you will see that the integration of the above requirements that I mentioned in the previous slide into the maintenance system and asset recording data and event as well as in activities and pushing warning notifications to the staff and management. So the digitalization of the asset maintenance, including provision of handheld equipment, barcode, QR code, refers to all the following in terms of asset reconciliation confirmation, viewing maintenance status, history, and pending items of work on the respective equipment, scheduling and assigning jobs to relevant persons through the handheld devices, and enabling digital completion of maintenance tasks, checklists, and job cards where they can fill it up digitally, as well as facilitating end user confirmation of maintenance work that's carried out. Also be able to raise corrective maintenance tasks from the completed job cards, check material availability, and link material codes for procurement process in terms of kickstarting that process where supplies are needed or spares are needed, and to generate approval flows within the existing SAP system that will allow for real-time and faster approval and generate the KPI status and maintenance compliance status. So all these systems that we are looking at must be compatible and be able to communicate with SAP. The next one is artificial intelligence-enabled 3D cutting and beveling machine. So here, what we're looking at, or the challenge that we're facing, is that we actually provide, as a shipyard, we provide a full suite of welding services for liquefied natural gas and transport vessels. And that includes both repair and maintenance for simple straight lines, as well as complex. When we talk about complex structures and ships, we're talking about curvatures and flat structures. And these ships are generally organized or separated into 3 sections, mainly the fore, the center, and the aft. And that's how welding services are categorized within these 3 sections. So are you doing welding in the fore, center, or aft? So the initial part of the welding service is to actually look at where the damage or the repair or maintenance is required. And if this occurs on the center sections, then we will have to resort to cutting and beveling of the damaged sections. This is quite straightforward. But if it is on the curved fore, as in the front or rear, the back aft sections, then a significant amount of planning and operation is required to enable cutting and beveling operations. So the front, as in the fore, and the rear, as in the back aft sections, they include pronounced curvatures, flares, and some uneven curvatures, parabolic profiles, as well as double curvature structures. So current process to do such repairs takes us about 48 hours to complete repair on 1 square meter for complex shaped structures. And this process is heavy on both manpower, and it also increases the exposure to environmental conditions for our staff. So we've looked at the market. Currently, commercially available semi-automatic, as well as fully automatic cutters, they are not able or capable to address the complex structures. So with that in mind, what we've decided is to look at, next slide, please, is to look at an AI-enabled machine that's capable of automatic plate beveling for 3D profiles. And that means, again, uneven curvatures or parabolic profiles or double curvature profile. And that is to reduce reliance on a manual beveling operation that is really determined by the skill of the person, and also to overcome manual beveling limitations on uneven structures of vessel shell plates. Also, the machine must be capable of automatic plate cutting in both the vertical and horizontal planes, and that cutting is to be done based on a repair plan that will be fed into the system. And this automatic plate cutting will then reduce reliability on manual plate cutting operation, again, which is dependent very much on skill, and also overcome the manual plate cutting operation limitations on marine steel jobs. And in terms of the materials to be cut and beveled, they range from mild carbon steel, stainless steel, and aluminum alloys. So the objective here is clearly to develop an artificial intelligence-driven automated cutting machine to speed up the workflow so that we can deliver safer, faster, and better solution. We'll move on to the next slide. In the next slide, so the requirement is that the machine should then be capable of sensing the curved edge of the steel plates and performing edge preparation in 3-dimensional curvatures, as well as cutting materials with the thickness ranging from 6 mm to 80 mm, and torch rotation in all directions, and operating with minimal manual intervention. So we want to limit it to maximum 2 operators, and reading both the PDF as well as the AutoCAD repair plans that are fed into the system, as well as operating in a dusty and high temperature environments that our shipyard is constantly exposed to. And the machine should be capable of being equipped with an oxy LPG acetylene torch for edge preparation. In terms of power source, is 230 volts or 110 volts. And it should be with or without guide rails, as in we could remove them or we could add them, as well as the setup should be portable. Let's go to the next slide. The third innovation that we're looking at is the fourth innovation that we're looking at is, excuse me, inspection and machining robot for inner water pipe maintenance. So we'll go to the next slide. Excuse me. So here the challenge is actually inspection and repair of pipes in the marine vessels. They will influence, and they're also influenced by the vessel's operation schedules, and current pipe repair methods cannot be undertaken while the vessels are in operation. So this is a severe limitation. So most pipes in the marine vessels are below 30 inches, and that makes them inaccessible for manual inspection and repair. And therefore, you need a large number of pipes to be dismantled to actually carry out the inspection and repair. Excuse me. So the solution that we are seeking is a custom-built portable pipe repair remote operated vehicle that can travel along the pipelines and equipped with a high-definition camera that will enable inspection as well as repair inside the vessel pipes while the vessel is operational. And what do we mean by that? It means the vessel is doing cargo loading or unloading, and these vessel inspections on the pipes are going on and repairs are going on at the same time. And also to reduce the number of pipes to be removed so that you only need to be able to just get at one end of the pipe system instead of removing a whole chunk of pipes. And also to minimize or avoid excess support like scaffolding and other support services which require manpower as well as time to set them up. So we've looked at the ROVs that are in the market. They can inspect, they can clean, maintain, and repair as well pipes and ducts as well as HVAC systems. But these ROVs are unable to meet the shipyard operational requirements. And also the ROVs need to be extracted repeatedly to facilitate the changing of tools from one function or in terms of inspection or repair and so on. So we want to minimize this. We'll go to the next slide. So the requirements of the remote operated vehicle robot that we'd like to look at are be able to enter carbon steel pipes ranging from 10 to 30 inches in terms of diameter, be able to visually inspect inner walls of pipes, and that is to detect all early corrosion pits, and also assess the thickness of the steel wall and perform in situ maintenance operations, which include patching, coating, as well as welding. Also be able to do inspection, surface preparation, weld repair, cleaning, and surface coating while the ship is operational. Like I highlighted, cargo is being loaded and unloaded. And also be capable of in situ power tooling. And this power tooling, it will be for both hot as well as the cold repairs, and be able to operate in vertical and horizontal positions as well as through bends, and to carry out a 3D, three-dimensional color camera system to inspect both the pipeline as well as spot defects. Now, we would like to have ideally a capability to record a video. So we've indicated that as a nice to have feature. It's not a mandatory one. And have a tool on the robot to mill out defects and then use another tool, as in we can select another tool on the robot to friction stir weld another patch to repair the pipeline, and enable the tools change within the pipe without having to extract the robot repeatedly, and also be able to travel and perform on any kind of pipe surface and environment, and generate an QR code reports upon job completion. So to facilitate this, you and be able to travel, the robot should be lightweight, portable, water, and flame resistant. I believe in the first innovation call, I probably missed out one slide. I'll just go back to that very quickly. That's on the requirements of the digital yard layout. I'm sorry about that. Let's just go back one more. Back. One more back. Yeah, one. That's right. Yes. So for the editable and interactive digital layout of the shipyard, what are we looking at? We should include locations of all major fixed assets within the yard, and I've indicated some of them in my opening slide, where I've given you an overview of the shipyard layout in terms of the cranes and where the docks are, and so on and so forth. And the system, digital yard layout system, must be able to retrieve data from the digitalized operations plan real time, and also any manual edits to the operations plan, and then be able to plot the confirmed vessels for docking. Docking is like parking in the relevant locations and the time slots. And that is based on the data that we retrieve from the operations plan, and to scale as well, because every ship has got its size and the docks have also got the sizes, and that will be based on the vessel sizes and other requirements like the crane operations. And this yard layout, which is digitable, must be editable and interactive, such that vessel locations and durations can be changed manually as required. That is to provide the operational flexibility for the vessel's movement. And also, like I indicated earlier on, is to generate caution notifications where any edit would result in a breach of a pre-programmed condition or restrictions. Like, for example, if someone were to get in there and trying to berth a vessel that conflicts with the space that is available within a dock, then that or implicate the unberthing of another vessel during the same period, then the system must be able to prevent or issue caution notifications in terms of feeding back this to the operator. And also feedback into the operations plan data in real time, and any manual edits that are made on the digital yard layout in terms of the operations plan. And so this digital yard layout changes should align and reallocate all the vessel durations and locations to the digital layout, and both ways. So it must work both ways such that the system is up to date at all times. So with that, I believe I've covered all the key points that related to the respective innovations, and I'll hand over to Dr. Abdul Haq.
Thank you very much, Mr. Nair. Really very clear presentation. Let me now show you how to submit the proposal. So you could go on our website. My colleague has already shared through the webinar chat the link to the website. This is what you will see, this page, you will see it on the QRDI website. You can select whichever opportunity or call you want to respond to. When you click, for example, for the first one, then it will show you the details of the call. By clicking on apply here on the down left side, it will take you to our partner 9 Sigma portal, where you will see the same description also there. So you could click on respond. Once you click on respond, it will take you to a page where if you are already a member of, or you have a registration with 9 Sigma, then you can just log in. Otherwise, you will have to fill the registration fields. And then once you do it, you will get the fields where you will fill your proposal. Please take care to do things, to fill all the fields and tick all the relevant boxes. Here are some tips for the submitting your proposal. If you are not done, you can save your whatever you want to input there, and then you can come back to it later, so you don't have to do it on one run or one chunk. At the end of the filling all the fields and ticking all the boxes, relevant boxes, please do not forget to click on submit. Otherwise, it will the application will not be considered as completed. Please note that for the first call, the deadline is 12 December because it was published a bit later. And for the 3 other calls, the deadline is December 5th. That's all. Now we reach to the Q&A session. Hopefully, I have seen that my colleague and also the subject matter experts from Qatar Shipyard have already answered many questions. I have here some questions. Let me first read the first one. Is there any conceptualization of the digital yard layout already thought of? Ms. Anaya, you are on mute.
Right. I will open this question to the subject matter experts, and I think if you're talking about the digitalized yard layout, I'll get Johnson or Praveen to respond to this question.
Yeah, thank you, Jian. I think if you're asking about the concept part, we do already have the existing process that we follow. So, and we do have the layouts of the yard. So we can say that, yes, we do have a concept which we are presently following, but it is not digitalized. So this is exactly what we are looking into converting into a digital platform.
So just to add on to what my colleague Praveen has mentioned, it is to have a digital twin of the shipyard layout, and that will then give us the flexibility. We have got a manual layout, as in the structures and all the equipment, as well as the facilities that are actually on a board, and we need to be able to translate them very quickly into the digital layout.
Thank you for your for answering this question. Next question: does the project include the procurement of sensors to be installed for monitoring the assets? This is, I think, for the second call.
Then I will defer to Scott. Scott, I believe you're online. Could you just unmute and respond to the question?
Yeah. Okay. So, good afternoon, everybody. I think initially what the call is for the digitalization proof of concept. So within the initial project would not necessarily be the sensors. That would come from having a proof of concept and then developing that into the individual equipment, of which the initial equipment list, there is an appendix within the Open Innovation call on the platform.
All right. Thank you, Scott. Next question: does the digital solution require any hardware solution together to achieve the real-time location data?
I think this goes for both Praveen as well as Scott, right? I think it's a question that's applicable to both. So, yeah, Scott, you want to go first?
Yeah. Okay. So, I think the simple answer to that is yes. Whatever proof of concept we get in terms of the digitalization platform needs to be able to communicate with various hardware and monitoring solutions that need to go onto the equipment, so that it can communicate. It can take the information, the live information from the equipment, and using the AI technology, then have that working within the platform to give us advanced warning of any potential equipment failures or change in condition of the equipment. And obviously, as we mentioned before, and Nair mentioned before, within the maintenance plans, we've got preventative maintenance, but then we have corrective, emergency breakdown maintenance. So everything needs to come together under a proof of concept digitalized platform and be able to communicate with the potential solutions to monitor the equipment.
Thank you, Scott. Next question: for the beveling and cutting machine, what are the maximum 3 dimensions of the curved plates you have in your mind? Nair, you are on mute, sorry.
Yeah, I'll get Praveen to answer the other question that is also related to the one that was partially answered by Scott in the maintenance side.
Okay.
Yeah, I think GN for us, for the digital platform, I don't think there's any external communication required or hardware involvement. So it's just directly from the planning that is done in software, which is being directly wired to the screen. So we would not require any external hardware requirement.
I hope.
Thank you. You are on mute, Mr. Nair.
Okay, now I think we can go on to the question. Sorry, we can go on to the question on the beveling machine, I think.
Yeah, the beveling and cutting machine. What are
Okay.
the maximum 3 dimensions of the curved plate you have in your mind?
Samrat, would you like to answer that, please?
Yeah. They all, we just to answer the question, the cutting machine in itself should be able to run based on the repair plans that will be given, that will be fed into the machines. If you're looking for piece-wise dimensions, and the maximum dimension that we are looking at each piece of cutting probably will be around 2 meter by 1 meter section on the curvature plates. But in itself, cutting machine, the cutting length can be depending on the repair locations. That can be from 3 meter varying up to 10 meter or 12 meter.
Thank you, Mr. Samrat. Next question, it is for the digital yard layout. The question is, what kind of pain point are you facing currently and looking to solve? I think you explained it in the beginning. Mr. Nair, can you just repeat it probably or explain it in other words if it was not enough clear?
It's pretty much a manual system that we are using. And so if you make a change to the layout, you got to go back and change the plan. If you make a change to the plan, you got to make it on the layout. And therefore, there can be communication gaps and there's no streamlined process. So we want these two systems to be able to talk together. And that's where we're looking at the digitalized layout as well as the edit portion in terms of the planners. So the planners can then update the data. And if there is a change that the planners make on the digitalized layout, they do not have to come back and make the change on the plan itself. It will automatically synchronize and update our plan. That's the whole idea behind. Praveen and Johnson, if there's anything to add, please ask. Thank you.
I think that's it. You covered the points. Basically, we are looking into a plan wherein the present planning that is done in Excel gets converted into a real-time a digital display. And that shows the vessel locations and because the process that we do is very dynamic. So it keeps changing maybe twice in a day or thrice in a day. So these changes must be quickly reflected, and it should be a live display that happens from the software change, what we do.
Thank you, Praveen. Next question, I think it's the same about the same call. What is the expected or preferred level of detail in the digital yard layout? Of course, it must include all relevant structures, but are you looking for modern visual, axle projection, or vivid colorization, or rather prefer clarity and straightforwardness of the more industrial grade graphics?
I can answer this. It's more of clarity And if you look now, it's something what we are looking into is something like, I could say, you might be seeing GMDSS chart for marine. So the depiction that you see in those charts is something what we are looking into, nothing of more detail. It should be something very clear and simple and straightforward.
Thank you very much. Next question, does the solution provider could be the solution integrated with different company startups? Can you just repeat this question? Because it's not clear. And if my understanding is right, is if you are having a consortium of startups, then the solution provider would be the representative of that. It's fine with us, but we need only one lead, I would say, company to work with Qatar Shipyard on one call, you know. So just repeat the question in other words if my answer is not clear enough. Next question. Do you have an interface in place which can retrieve data from sensors, IoT, or any other sources?
I think I'll take this one, Nair. I think it's related to plant and equipment. We do to a certain extent. The yard was obviously commissioned in 2010, so we have got some integrated systems like power management system, for instance. We've got ACS 6000 dewatering pump drive systems. The floating dock has got an IDAC system, but everything is not really interfaced and together in that extent. So it's very segmented, if we should say. Now, what I have had a few questions on is the list of equipment that we were looking to implement this on. There's an Appendix A in the call, and that's just our initial first level of digitalization that we would be looking at. But if we then look wider afield, further down the line, if we get a concept in place, ideally it would be that it would bring in the power management systems, it would bring in the fire alarm, it would bring in the floating dock IDAC systems, and be able to have a centralized, digitalized platform that monitors everything on the yard, as we said in the call, to bring in something like 20,000 assets. And some of that can be captured via, say, power management system, which monitors the 35 substations that we have on site. So it's a combination of standalones and integrated systems that are capture, say, electrical performance and electrical usage and status, but not really integrated into a whole digital platform that I can use or my team can use as early warning, predictive maintenance, etc.
Thank you, Scott. Next question, are there any specific SCADA or PLCs installed from PDMPS?
Okay, I think as probably my previous answer covers that, because there is certain SCADA systems involved in the PMS, etc. But I think that can only be answered when you look at the individual items in the appendix.
Thank you. Next question, are you open to using mobile devices, iPad or equivalent, for updating the shipyard operation plan, or only computers?
I think I should answer this. I'm not sure how relevant that is, because it doesn't matter if we do the plan change on an iPad or a mobile device, but basically it's done at office. It's not done at site. So I would say preferable is a laptop or computer.
Thank you, Praveen. Next question, the AI 3D cutting machine can be welded to hull of the ship for the cutting? It's just a question.
I'll take this up. We
Yes.
prefer this should be a portable setup that should be able to change from location to location. If it is welded to one location, will not be able to utilize these machines at different locations as per requirement. And the machine has to be able to move on different projects as per requirements. So no, as of now.
Thank you, Samrat. Next question regarding the digital assets and predictive maintenance technology. Does proof of concept is sufficient, like acquiring data and diagnose failure, remaining live and visualizing on the screen, or should it be integrated into the platform that is currently available?
Okay, so I'll take that again. I think we're running on SAP plant and maintenance module at the moment. That's where all our data is stored on the existing assets and equipment and maintenance plans. Does it need to be operated under that? No, it needs the platform that we have. As it said in the call, we need to have ability to have early warnings. We want to be able to run the maintenance plans on, say, handheld devices, complete the maintenance plans in real time. So the platform that we end up with, we can be running on a separate platform that combines all of the information, but also extracts and communicates with SAP for either updating or extracting historical data and integrating the real-time data from the equipment.
Thank you, Scott. Next question for the digital asset and prediction. As the assets are manually measured, how you will assure that the measurements are done in the right time, and how should be uploads to the platform?
Okay, so at the moment we don't have anything apart from, as I said, like the PMS system. We do have some systems that monitor the air conditioning, but again, building to building, they're very segregated. What I would say is that at the moment we've got we've got CBM tools that are manually brought to site for doing vibration analysis, ultrasonic, thermography, etc., and that's done on demand. We have done some baselines of about 344 items of equipment to give us CBM baselines, but that is then put into a separate platform or assessed by a consultant, as we've had here, to do the baselines, to then say, right, okay, we have some early warnings on this, we need to continue monitoring. That monitoring then becomes predominantly a time-based, or if there's a concern based from the engineer, to ask the asset integrity team to go down and do some additional monitoring, or we set regular monitoring targets for specific equipment. What we want to have on this critical equipment is the ability for the remote sensors to be installed, for that to come back into the platform, give us the early warnings, give us the data we need, etc. So we don't have, and to answer the last part, we don't have anything that uploads into our current SAP system. It's not that dynamic at the moment. It's all manual entries.
Thank you, Scott. Next question is not clear to me, at least. Does the final solution can be combined with other solution? Can you please rephrase your question so we can answer it? Next question, digital layout plan. You mentioned AI capability in the call. What do you expect from AI in this context? I think Praveen.
Sorry. Jian, I think that's again something which is not correct. Maybe we are not looking into any AI capability into the product.
Okay.
That's absolutely right. For the digital asset and predictive maintenance, for the digitalized dynamic shipyard operations, we did not mention the AI. The AI is only mentioned in the AI-enabled 3D cutting and beveling machine.
Thank you for this clarification. Next question, we have developed the platform for the process automation and digital workflow, which can talk to a machine, or inputs can be from SAP or manual data entry like check sheets. We have the ready-made platform for this, and we can do quick demo. Okay. So please submit your proposal, and then there is no question here. Next question. Is it possible to get an example of operation plan, at least a short extract? Is the question not clear?
Yeah, the question is quite clear. Only thing is we'll have to make a dummy plan maybe, and we can share. Yeah, can, no problem.
All right. Thank you, Praveen. Next question, what shall be the maturity level of the solution for digital platform during the process of application? How the IP right will be handled in Qatar Shipyard? Is Qatar Shipyard hold any ownership of the development solution? What I can say from our side as QRDI does not own IP rights, but from Qatar Shipyard, I led the team to answer this question. Now you're, yeah.
Yeah, Scott, do you want to answer that question?
I don't think it's my area of expertise, to be honest.
Yeah, I think
Gian, this is for the digital platform again. I'm not very sure. We have Yunus here from IT, but the platform that we are talking about and what we are looking into, that need not be like, that does not warrant this IP rights and things. I don't think so, because it is going to be a standalone software which will be having the data is going digital into a display. So I do not think that this might be relevant.
Thank you, Praveen.
I will just add on. Sorry,
please.
I'll just add on to that point. I think at this point, we need not worry too much about the IP. We can discuss that during the solution development phase. And the idea is to develop something that is contextualized for our shipyard. And once that is successful, then you will have a generic model that you could, the solution provider could then market to other shipyards, right? And that's where you carry that IP for that portion, and we get a product at the end of the day, which is contextualized to our shipyard. So I hope that's clear.
Thank you, Mr. Nair. Next question, can we get access to the sensor data, or we will have to simulate the behaviors?
Okay, as I mentioned before, that we don't have predominant sensor data. We've got like a power management system, but on all critical equipment that's in the appendix, we don't have remote monitoring data at the moment.
All right, thank you. Next question, this is why I asked the last question. There is a mobile requirement here. Is it only for plant maintenance transactions? No.
Okay, I'm a little bit unclear on the question. If you're talking about mobile equipment, at this moment in time, predominantly not. All the equipment in the appendix is static equipment.
Thank you, Scott. Next question, do you also have any MES layer for production and planning in your current automation stack? To whom is this question?
Could you just repeat the question once more, please?
Do you also have any MES layer or production and planning in your current automation stack? It's not clear to which.
I think the person who is asking the question is quite clear, but we are not able to. I'm not sure what is MES here. I'm very sorry. We don't use it, so I'm sorry, can't answer this.
All right. Thank you. Please reformulate and reword your question. Maybe we can answer it. Next question, for the digital asset and predictive maintenance, do you require a solution that is able to do all vibration, audio, thermo analysis? Or are you also open to solutions that utilize underlying current and voltage data on your rotating equipment to detect the most critical failures of your equipment?
Okay, I think to answer that simply, it's dependent on each type of equipment, to be honest. What we would want the software to do is to be able to take all of those different types of input, whether it be vibration, audio, thermal, and any other analysis input, to be able to then process and assess each individual equipment. So the system would need to be able to pick up the individual types of equipment and the relevant inputs that are required relative to that type of equipment.
Thank you, Scott. Next question, for the digital assets and predictive maintenance solution, are you open for using a cloud-based solution? I think the question would go to the IT.
I think that we have no preference. Is it on-prem or cloud? We are open with both. Depends on the system requirements, but also cloud is acceptable.
Thank you, Mr. Mohammed. Thank you. Next question, can we get, for the predictive maintenance, can we get access to the sensor data? And we will have, I think you answered this question already.
Yes, I have, yeah.
Yeah. Next question, could you share sample yard layout drawing with dimension for preparing and use case check-in? I think a similar question passed before.
I think GN can answer this, but GN, I don't think we can share the yard layout incomplete. Whoever is developing will have to use any sampled layouts and then develop it, please.
Thank you, Praveen. Next, what do you expect from AI of the cutting machine?
Okay, I'll take up this. What we are looking is during before cutting operation, basically what we feed into the machine is a repair plan that will guide the machine exactly on the cutting line that has to be followed. What we are expecting from the machine is to take these repair plans, read, understand, and then while executing, it will have to map up a reference point from where it can start its cutting operation. And once the cutting operation is completed, we are looking for a feedback from the machine, as in a report that can be generated after completion of operation.
Thank you, Sam, for this clear answer. Next, do you handle all the data models or asset tags somewhere, or are they shared from multiple sources for digital assets? I am hoping this will be from different sources.
I'm not sure on the question really. All our assets have got tag numbers that are in SAP PM module. So we have got tracking in there. I'm not sure how to answer the rest of the question.
All right. So maybe whoever asked this question can reword it. Maybe we can answer it. Thank you, Scott. Next, how will you assess the performance of PDM model during pilot phase?
I think it'd be handy to clarify PDM. If it's preventative maintenance, then it's down to the proof of concept and being able to extract and be able to compute all the necessary information from the relevant equipments and be able to then develop that into active maintenance planning.
All right, thank you. Next, it's kind of a remark or with a question. So you expect us to propose remote sensors or equipment to be purchased and will work in a plant network. Is this what you're expecting?
Okay, so what we are expecting is a platform to be able to utilize the information from the condition-based maintenance. Does the initial proposal need to include the remote sensors? No, but it needs to have the ability to take the data from remote sensors that we currently do not have. I think at a later stage, if we have proof of concept and we go ahead with a solution, we need to know that the platform will be able to accept that raw data from the equipment contained in Appendix A.
Thank you, Scott. Next question. Could the digital layout application be a cloud solution? I think we said yes. Is there a preferred cloud server like AWS, Azure, Google? Does the data shall be stored on Qatar Shipyard owned virtual machine? This is probably from Mr. Muhammad Yunus.
To answer this question, actually, the application can be hosted on cloud, Azure or Google. We have a preference of for Azure and Google Cloud, depending on the specific requirements of the application. And for the data storage, it can be cloud infrastructure or within our Qatar Shipyard local virtual machines, depending on the requirements for the data residency and the performance at the end of the day.
Thank you, Mr. Muhammad Yunus. Next question for the digital layout. It's kind of just clarification. Vessel locations and duration means at which pier dock is a vessel and how long will it be there?
Yeah, that's 100% correct.
So just to add on to that, I think the earlier question was about the layout. The layout that we had shared in the presentation, that could be used for indication purposes to develop a test case.
Thank you, Nir. Next question. What amount are you expecting for investing in the digital assets and predictive maintenance project? Since it is an innovative project and can be done in variety of ways, ending with the modeling.
Scott.
Yeah, I don't think that's a question we can answer at the moment. We need to see what platforms are out there and how that would fit with our technical solution. And then I think the commercials are a separate discussion after that.
All right, I think this was the last question that we have. Okay, still one more question. Do you use both GIS coordinates, latitude, longitude system and local coordinate system, XYZ, based on a common base point at the premise of the yard? This is probably for the second, for the digital assets, probably.
Yeah, sorry, is that for me?
Probably. You want me to repeat the question?
No, I've got the question in front of me. The plant and equipment, we don't use geolocation or anything like that or coordinate systems. If you're talking about the yard layout, I think there was a grid system at time of construction based on easterns and northerns and coordinates, if that answers.
Yeah, but if it is for the digital model, then we don't need it.
All right. Thank you, Praveen. Next question, are you expecting us to cover up the GUI for SAP plant maintenance for the digital asset transaction in this request?
I'm not quite clear on the question, to be honest.
Actually, I'm trying to translate the question. Are you expecting us to cover up the GUI for SAP plant maintenance for the digital assets transactions in this request? Actually, as Mr. Nair mentioned in the beginning of the presentation, that the solution should have the capability to integrate with SAP to push information, data, records, because SAP is our main core backend system for this, and the system which we expecting in this regard supposed to have the API integration capabilities to integrate with SAP S/4HANA.
Thank you, Mr. Mohammed Yunus. Next question is a rewording of the former question, I think. And it said now it's for the digital layout. Do you use both GIS coordinate, latitude, longitude system, and local coordinate system, XYZ based on a common base point at the premise of the yard? I think.
Yeah, we answered this earlier. It's
Yeah.
it's not actually required for this project.
All right, thank you. Next question, create a new user interface on top of SAP PM. Didn't get it well.
Yeah, that's an SAP plan and maintenance. Scott?
Yeah, I think that's already been confirmed with both my last answer and also Eunice's.
Yeah. So the answer is yes.
The answer is yes, thank you.
And sorry, just to confirm in simple terms, SAP, we have a commitment on SAP, and certainly the plant and maintenance module, we can't shift from that because of Qatar Energy interface. So we need something that can communicate with SAP, extract data, as Eunice had said, and then also integrate the CBM elements and monitoring from whatever platform can integrate with SAP.
Okay, thank you. Next question regarding the positioning of the digital twin challenge. Is there a LORI, WAN communication infrastructure in place? If negative, what comms work best in the shipyard? What communication works best in shipyard?
This is better answered by Eunice on the WAN communications, wireless network communication.
For the long range and for the wide area network range, we can provide whatever is requested from application requirements on terms of the network. And the whole shipyard is covered by network communications end-to-end back into our data center, and even from our data center up north to the cloud as well, if the application will be hosted on the cloud.
Thank you, Mr. Mohammed Yunus. Next question, for the internal pipe robotic inspection and machining, what would be the KPIs to satisfy a POC, especially considering the price value? Do you need a robot to be deployed, or it's sufficient to showcase the principles and then only building the robot once the POC is completed and accepted? Nair, you're on mute. You're on mute, Nair.
Is it okay now? Yeah. Selva and Vijesh, I think this is a question for you. Finally, there's a question, no clarification on your innovation. So go for it.
Okay, taking up this. Okay, actually, we required the robot which is a fully function, which is not similar to what we have in market currently. This is a special because we want the robotic is fully built in like with the AI support. This enter to the what you call the pipe to be to inspect and also to decide what kind of a repair we can handle on that. And also the machine, that means the robot, which will be able to what you call adjust the size according to the pipe, which is we require like a 30 inch to the 24, 30 inch to 20 inch.
All right, thank you very much. Next question, are you comfortable in setting up MQTT broker on your existing models by using the digital assets and predictive maintenance projects by us? Sorry, in the digital assets and predictive maintenance project. I think it's to Scott.
Yeah, I'm not sure the abbreviation of MQTT. If we're talking again about a platform over and above the existing SAP PM module, then yeah, we're okay with that. But I don't understand the MQTT.
All right. So please reword or explain what is MQTT. Next question, any data processing limitation, e.g. if in cloud, then the cloud should be localized, private data requirement from the security or a governance standpoint. This is probably to Mr. Muhammad Yunus. The question is not clear.
Yeah. To be honest with you, this needs to be assisted. We have a private cloud, Azure private cloud in our data center. So after we have that application or the proof of concept is ready, we can after that try to do some analysis about the clouds in sense of sensitivity and if it's also, let's say, confidential. And if yes, then it will remain in our side, in our data center, in our private cloud. And other than this, it can be in public cloud, as I mentioned, regardless if it's Azure or GCP Google one.
All right, thank you, Mr. Muhammad Yunus. Next question is a programmatic question. By when we get to hear the results, also how to contact 9 Sigma team to review our proposal. So the results, you will get them by second month of 2025, around February 2025, because the deadline for submitting proposal is in December, and we need about 2 months to complete the evaluation process. I think once you register with 9 Sigma, then there is a contact person there, and then you can contact Dr. Oliver from 9 Sigma. Okay, back to the pipe robot question. Is it okay if the pipe patching is delivered via laser bed additive manufacturing?
Is a laser bed additive manufacturing? I think this is not required at all, because we are requiring for the what you call the patching is not a patching work, because we have to do the like a what you call like a welding or sometimes some kind of a build up, because we have pipe or steel pipe.
All right, thank you. I think we have these 2 last questions, and then we should stop here. Could we combine the projects together with other grant support investments received from innovation supporting organization institution? This is up to you. At the end of the day, what we want is something that is, that satisfy our client here, our partners, Qatar Shipyard. If you have other source of investment, we have no issue with that. Next question, do we also need to submit a platform demo in our proposal and any similar work we did? You can submit examples of proposals or projects you did before. It's fine with us, not within the proposal, but as additional, information, you can add attachments as much as you can. Okay, we got two more questions, I'm sorry. So in our proposal, we will outline how the robotic crawler will be deployed to conduct some machining works as part of the POC, but then commercialization of the robots will carry different terms and conditions, correct?
Yes, exactly.
Mr. Nair?
Yes, exactly. We are preferred for that because why? Once the robotic crawler was crawl go inside the pipe, so he will be detect the area where we are to due to be attend. At the same time, he himself will be respond to what kind of a repair to be carry out. And also the crawlers also have to be able to crawl either in what you call 0 degree or 90 degree.
All right, thank you very much.
Just to add on to that
that's
question, the answer is yes. You will need to outline how the robotic crawler will be deployed as part of the proof of concept, and commercialization will be a complete different phase altogether. So we'll do the trial, get to the proof of concept, do the demo, and then we'll move to the commercialization separately.
right. Thank you, Mr. Nair. Last question, is there a direct match? If there is a direct match with a couple of the challenges by the same applicant, will you pursue collaborating with the same supplier on two different projects simultaneously? From our side, if I understand well, you want to apply for two different calls. From our side, we don't have an issue. However, from Qatar Shipyard, I let Mr. Nair to answer this question.
No, in theory, no issues as long as the innovation opportunities are seen as individual innovation opportunities. They're not blended. But yes, we can consider if you're submitting for more than one, because you may have expertise in the related areas. So we're happy to hear that. Thank you.
Thank you very much. So now we reached the end of the webinar. I would like to thank Mr. Nair and the Qatar Shipyard team for their clarification regarding the innovation opportunities. I would like to thank everyone who attended the webinar, and I will look forward to receive your proposals and hopefully working with you on developing your pilots in Qatar. Have a nice day.